Hey everybody, I just want to go through and talk about the original problem, the problem number one on the review guide so that we can go through and you can see sort of my thoughts. I'm kind of just going to talk you through it. If at any point you have a question or something doesn't make sense, the nice thing with this is you can just rewind. So we're trying to solve a cow that's running at 14 meters per second. It doesn't see a 23-meter high cliff, so it falls off. So basically, top of a cliff, cow is going to fall off. So we have to figure out the final speed, really the final velocity with which the ball, with which the cow hits the ground. So that's our VF. And we also have to find how far, so that would be our range, our dx that we have to find. So we'll start with part A first, and I'll do that on the next slide. There we go. All right, so clear this. Just going back, just going back and trying to find our overall result is we have our cow, redraw it up here, cow going towards the side of the cliff at 14 meters per second. That is our, if we set up our table in terms of vertical and horizontal, that would be our Vx, our initial horizontal speed. That doesn't change. There's no such thing as Vix and Vfx. Just regular 14 meters per second. We're going to be looking for time. Time's the only thing, I think I made that too small, is the only thing that crosses the bridge. That usually is step number one, to try and find time. Or at least possibly try to find time. We're going to be looking for it to try and solve something. So, we may need that. Other things we're going to need, we already realized from part 2, part B is going to be finding dx, but we know a couple other things. VIY is always 0. That doesn't change. AY is always negative 9.81. That doesn't change. Meters per second squared, I just sort of didn't put enough space for the units. And the other thing we know is this height, the height of the cliff, because it says in the problem that it's 23 meters. But again, because the cow is falling downward and ending lower than where it starts, put it down here, our dy is not just 23, it's negative 23. So we're going to have to find time, let me cross that out here, and make a better, bigger time. There, because time still crosses that bridge, allows you to find horizontal and vertical. All right, so the first thing we have to do is we should be looking to solve our triangle. Overall, we want to solve for the hypotenuse, which is this one. We want to solve for that because this truly is our final velocity. We know this is our initial horizontal speed, and this part of the triangle is always and only our final vertical speed. So what's going to happen is the cow's going to fall down, and right before it hits the ground, it's going to be traveling somewhere down, both downish and outish. This arrow right here is the same as the hypotenuse, and we have to find how far out and how fast down the cow is going. So to do that, we already know Vx. We know that Vx is 14. But now we need to find VFY. We got to sort of fill in this triangle by going counterclockwise. We're also going to need to find this angle as well. But we know how to do that. This is a vertical piece of information, so we have to look only at our vertical side. We know VIY is 0, we know AY, we know D. We're looking for T. So if you look on your little half sheet, you should be able to find the equation, and this is the equation you almost always use for time. dy equals VIYT plus 1/2 AY times t squared. You almost always use this equation to find time. Because just about always we know, well, we always know VIY, we always know AY, and there's one of two options. We either are given VFY, in this case you don't have to find time at all to find it, or we know dy. In this case we know dy, so we have to use it to this equation. If we knew VFY, we would use a different equation. The VF squared equals VI squared plus 2A, VF equals VI plus AT to find time for that situation. But this is what we're left with, and when we start plugging in, our negative 23 equals 0t plus 1/2 times negative 9.81 times t squared. 0 times anything is 0, so this whole term goes away. And you're just left with negative 23 equals 1/2 times negative 9.81 times t squared. Take it out the calculator. Well, really simplifying this first. Negative 23 stays the same. Equals 1/2 of negative 9.8 is negative 4.905 times t squared. I'm just going to skip a step, but you should be able to understand. You divide by the 4.905 to the other side. That's going to give you 23 over 4.905. That's going to give you, divided by 4.689. So t squared equals 4.69 seconds. So to find t, you just take the square root, and you get a time of 2.16 seconds. All right, so now what do we do with this? You may be thinking to yourself, Recore, what's going on? Why do I need to find time to find VFY when I have this equation? VF squared equals VIY squared plus 2AY d. And you'd be right. I didn't need to find time to find this. It turns out that I do need to use time for part B, so I needed to calculate it anyway. And what I do when I solve these problems, I just overcome myself, I'll be honest. When I find these problems is, if I can find time, it's always useful to find it, because it's something that is 99% of the time used in one part of the problem or another. So I found time, and that's going to save us in part B, which we'll come back to. So now I can find VFY. I could also use my time to do that with just VFY equals VIY plus AYT. VIY is 0. So this is negative 9.81 times 2.16. Negative 9.81 times 2.16 gives me a VFY right here of negative 21.19 meters per second. So it's going down. Vx, Vfy. Rest of the problem is to find Vf and theta. While we're thinking about it, we also had to solve for part B, was solving for dx. And dx, so we're just putting part A on hold for a second because I'm going to need a little bit more room, so I'm going to have to erase something in a second. But while we're thinking about it, we can solve dx. We have enough information. For horizontal stuff, we only have this one equation we have to deal with. dx equals vx times t. We're looking for dx. This dx is how far from the cliff the cow will land. So dx, what we're looking for, already solved. Our Vx up here is 14 meters per second. And our t, our time, we just solved for. See, I told you we would need that time. So our dx, just multiply those two together, 14 times 2.16 is going to be 30.24 meters. This has seconds, seconds cancel out. So that's our part B. And again, we needed to use that time, so solving for it in the first place wasn't a frivolous thing. I needed it. I would have had to solve for it anyway. So we found part B. That's checked off. That's done. I'm going to erase this, but I will redraw this triangle in a second because we have to find just two more pieces of information, VF and theta. So to find VF, oops, sorry guys. To find VF, I need to redraw. My Vx was 14. My Vy, my Vfy was 21.19. So I got to find overall VF, Vx 14, Vfy 21.19. My combination of the two is really what VF is. And that I have to use Pythagorean theorem, which says that VF squared equals Vx squared plus Vfy squared. This equation you will see on your quiz, by the way. So, plug in. 14 squared plus 21.19 squared. That gives you 14 squared plus 21.19 squared. That gives you 645.02 is V squared. So we have to just take the square root. When you take the square root, you get the answer, which is printed, of 25.40 meters per second. On the sheet it says 25.44. It's all a matter of rounding. That is completely acceptable, completely the same thing. I've done this problem two different ways. First time I did 25.44, this time I got 25.40. So you're fine. Last thing we need to find, so that is just this, 25.40. That's only the speed though. Velocity is a vector, so it has speed, it's 25, not 24, has a speed, which is the 25.40, but it also has this direction, which we have to find. And you know how to do that. Theta equals the inverse tangent of the opposite side of the triangle. Here's our angle, so on the very far side, 21.19, over the adjacent side of the triangle. Here's the opposite. This side's the adjacent because it's the side that's touching the angle that is not the hypotenuse. So over 14. When you plug that in, inverse tangent, make sure your calculator's in degree mode, over 14, you get 56.55 degrees. So 56.55 degrees, putting these two things together allows us to fully classify that velocity vector, and we get our final velocity, not our final speed. Our final speed is this, but our final velocity would be 25.40 meters per second at 56.55 degrees below horizontal. Below the horizontal, here's the horizontal. I have to rotate my vector, my hypotenuse, down. I have to rotate it below, which is where this BH comes from. All right, so hopefully that clarifies question one. We already found, so this is really the result from part A. In the previous, a little earlier, we found the result from part B to be the 30.24 meters was our dx. And again, on the worksheet, I see that it says 30.32 meters. They're the same answer. It all depends on rounding. So hopefully this clarifies question one. You will have one of these types of questions on the quiz. 2 out of the 3 of the questions gone over in the next screencast will be on there. So hopefully you can understand. If not, go back, rewind, watch this again. I know you like to see my face. So good job, and we will continue from there.